Scientific notation. I want to start this discussion by looking at powers of 10. So let's start with 10 to the 0. We know that any number to the 0 power is 1, right? 10 is no exception to that. So 10 to the 0 is 1. Now, 10 to the first, right? A lot of people like to remember that the exponent is the number of zeros. So 10 to the first has 1 0. 10 to the second is 10 times 10. 10 to the third is 10 times 10 times 10, so we've got 3 zeros. 10 to the fourth, 10 times 10 times 10 times 10, so we've got 4 zeros. Now let's go look at the negative exponents. It's a little more interesting. So we have 10 to the negative 1. Remember what that means. That means 1 over 10 to the first, which is 1/10, which is the decimal that we see here. Remember, the first decimal place is the tenths place. There is no oneths, right? The very first decimal place is the tenths place. Then we've got 10 to the negative 2. Remember that that is the same as 1 over 10 to the second, which is 1/100th, which is what we see here in decimal form. And we can keep going, right? This is 1 over 10 to the third, which is 1/1000th. This is 1 over 10 to the fourth, which is 1/10,000th. And that's what we see here in the decimal forms of the numbers. All right, so we're good on powers of 10. Let's see how we can use this in scientific notation. When you are changing a number from standard form, which is what both of these are both in standard form, to scientific notation, these are the steps we're going to follow. So let's do them one by one. The first one says, place the decimal so it's a number between 1 and 10. Okay, that seems pretty easy. So I'm going to place it right here because 4.5 is bigger than 1 but less than 10. Check. The second step is write that number, okay, and then times 10. This is the setup for our scientific notation. And then the last step, how do you get the decimal back where it started? Okay, so I placed it somewhere, right? But how do I get it back where it started? I would have to go 1, 2, 3, 4, 5, 6 places to the left. So that 6 places to the left tells me that my exponent on my 10 is going to be -6. That's it. This is my number in scientific notation. Let's try this one. We're going to follow the same steps. Step number 1, place the decimal so it's a number between 1 and 10. So in this case, I'm going to have to put it right here, right? Because if I put it after the 5, 95.4, that's too big. If I put it in front of the 9, that's less than 1, right? 0.954 is less than 1. So it's got to go right between the 9 and the 5. Okay, step 2. Write that number, so 9.54, and it's unnecessary to write all the zeros, right? Because just like if we had 3.5, we're not going to write 3.50000000 all the time, right? So 9.54 is good enough. So step number 2, check. And then how do you get the decimal back to where it started? Okay, so here's where I placed it. Now, there was no decimal when I started, right? Probably thinking that. When there is no decimal in the number, then the decimal point is at the end. So we want to know how to get it back all the way to the end of the number. So that means I've got to go 1, 2, 3, 4, 5, 6, 7, 8 places to the right. So this time, oh, I forgot the rest of this part. I forgot to write the times 10 part. Let me write that in real quick. All right, I write your number and then times 10. And now I'm going to get my exponent for the 10 by looking at this. I had to move 8 to the right, which means my exponent is a positive 8. Dun, 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 dun. So there I've got a very small number and a very large number written in scientific notation. And this is the purpose for scientific notation. Not to describe things in our everyday life. If I'm going to measure the length of my cell phone, or if I'm going to measure the diagonal length on my TV, I'm going to use, regular measurements. I'm not going to use scientific notation. But for astronomy, right, measuring anything that has to do with space, those are huge numbers. Or for things that are very, very small, like subatomic particles, those are very tiny. So we need scientific notation, because if not, the amount of zeros in these numbers would fill the page. And then what can you do with that? Like a whole lot of nothing. It makes it very cumbersome to work with these numbers if the whole page is zeros and it's all just for one number. Okay, so now let's go the other direction. We went from standard to scientific notation. Now let's go from scientific notation back to standard. This direction is a little bit easier. So step number 1, move the decimal point the number of spaces. Oh, actually, there's only one step. Move the decimal point the number of spaces and direction shown in the exponent. So just like we saw last time, if it's -5, that means 5 to the left. So I'm going to take my number, which is 2.1. So here it is, 2.1. And I'm going to do exactly that with my decimal. I'm going to move it 1, 2, 3, 4, 5 spaces to the left. And I'm going to fill in all those spaces with zeros. You could also put a 0 in front of the number, but it's not required. So we've got 0.000021. Done. Let's take a look at this one. I'm going to do this one down here. So again, I'm going to write my number. And then this 4, it's a positive 4, so that means 4 to the right. So it's getting bigger, right? If I'm going to the right, it's like I'm multiplying by 10. If I go to the left, it's like I'm dividing by 10. Or I am, not like I am, I am. So 4 to the right means 1, 2, 3, 4. And I fill in those little swoops with zeros as well. Let's look at one more type of problem, and that would be comparing numbers in scientific notation. How many times larger is this than this, right? Think about what you do when you want to know how many times larger something is. If I asked you, how many times larger is 12 than 4, you would tell me it's 3 times larger, right? Because 12 divided by 4 is 3. Or maybe you're thinking of the fact family. 4 times 3 is 12. So when we want to know how many times larger something is, we have to divide. So how many times larger? And it may just say how much larger, but then in the answer choices it might say this many times, this many times, this many times. So don't be confused, because a lot of times how much larger means subtraction. But if you're talking about in terms of how many times, then that means that you have to do division. So how in the world are we going to do that? How are we going to divide these? Well, we're going to divide this part the same way we always do. So 8 divided by 2 is 4. That part's easy peasy. This part is not much harder. we know how to divide these. We learned it in, what, like 2 lessons back, 2 videos back? So we've got 10 to the 5th divided by 10 to the 4th. 5 minus 4 is 1. Or I could just write 10, right? 10 to the 1st is the same thing as 10. So I get 4 times 10 to the 1st if I want my answer in scientific notation. If I want it in standard form, that's just 4 times 10. 40, right? Or if following what we just did, this 1 means that I move this decimal point 1 place to the right, I would also get 40, right? But again, I think it's easier just to think of it as 10 to the 1st is 10. So 4 times 10 is 40. So how many times larger? It is 40 times larger.